Hi, my name is John. Welcome to the ScienceLogic product video series. Today I'll demonstrate how ScienceLogic can help you dramatically decrease the time it takes to diagnose and resolve service-impacting issues with behavioral correlation. Let's look through the lens of a fictional company to demonstrate behavioral correlation. Michael KINCAID is a global luxury retailer struggling to find intermittent service issues affecting their global IT estate. They have infrastructure spanning most of the largest cities around the world supporting mission-critical services. As in most large enterprises, there are vast amounts of data spread across multiple complex technologies and data silos. While a typical enterprise will hunt down hundreds or thousands of events or incidents via an event or ticketing console, Michael KINCAID has SL1 to elevate the enterprise visibility into service health, going from a low-level device view to a business service view in order to quickly filter out the complexity and noise. Let's take a look through this service view when a system is no longer healthy and you know immediately where to focus your team's attention. I'm going to drill into e-commerce. Here you can see the e-commerce service is made up of 3 regions: Asia Pacific, Americas, and EMEA. The source of the business impact is the Americas region, more specifically from New York, where several areas of infrastructure management have been lit up with different severities. I'm going to select New York infrastructure since SL1 is highlighted at red, so I know intuitively what to click on next. Now we can see exactly when the service degraded. I see there are a number of anomalies. Here we're looking at throughput to the storage platform. Let's look at 2 data sets. The blue shaded area is the predicted normal range for typical throughput. The green line is the actual throughput over the past several hours, and the red dots indicate values that SL1 had deemed as anomalous. Historically, everyone has used either static thresholds or baselines to detect problems. Machine learning introduces new capabilities around pattern recognition. In this case, everything was up, available, and moving data to storage. Nothing out of the ordinary that would raise even an eyebrow. After all, utilization was at 45% and there was no outage. But the machine recognized that data stopped fluctuating and went flat at 45% utilization. In other words, it was capped or maxed out much lower than it should have been. It was this detection of the abnormal pattern in frequency that triggered the anomalies that warned of a degradation in service delivery. After machine learning identified that the throughput to storage went flat, engineering dug into it and found that a config change had occurred right before the flat period began. They then realized that there was a misconfiguration that had initially gone undetected. After all, everything was running and there was no outage. Once engineering restored the proper configuration, things returned to normal. What is crucial about this ability is that SL1's machine learning was applied to the raw performance data, not on static or baseline-based events like other products. Therefore, ML systems that depend on events from legacy monitoring systems never catch anomalous patterns in the raw data and miss entirely these types of behavioral anomalies. In addition to the throughput issue, we also have a server problem. As you look at your events, you get a quick preview of performance data, user actions that are specific to the event, as well as historical data on the device. Since this was a server-based event, the user is presented with both recommended diagnostics and remediations that can be initiated with a single click. Let's select the file system data diagnostics. As soon as it runs, you can open the logs to see the details of the diagnostics that you just initiated. Here we see a number of commands that were run from that single click. An operator would typically take 5 to 10 time-consuming steps in order to collect all of this data, but it also enables new staff to work like experts on their first day. Remediation actions can be run as well. I'm going to kick off the recommended procedure to clear the cache. Now that it's run, let's look at the log. Here we see an update in the log that the clear cache action ran and removed the cached package files, freeing up disk space. And the storage situation has now been resolved. You've just seen how with SL1 you can rapidly identify and diagnose service impacting issues, apply machine learning to raw performance data, and leverage recommended actions such as diagnostics and remediations. Thanks for tuning in. For more information, please go to ScienceLogic.com.